Hi again, everyone. We're going to do chapter 5 now, which is factoring polynomials. And there are different types of factoring, and we'll go through several of the different types. But this is basically undoing the multiplying. It's a lot like dividing, but you don't see the division as much. And so we're going to do all the different types of factoring that you've probably heard of somewhere along the way in a previous course. So the steps, first of all, every single time, make sure that if there is a greatest common factor, you factor that out first. So that's step one. That's the biggest number that will divide into every term and the smallest exponent shared by every term. So you're looking for the biggest number to divide into everything and the smallest exponent that would go into everything. Take that out first. After that, then it's going to run into different sets of rules. If you have 4 terms, we can do it by grouping, and I'll tell you what grouping is. If it's 3 terms, we're kind of doing the reverse of FOIL. So we're going to look for signs that are either the same or different, and then how they add up to give you the middle number and multiply to give you the last number. So we'll go through those steps. Or if it's 2 terms, we're going to look at 3 different formulas. And I kind of mentioned this, some of this difference of squares in the last video about multiplying things together. But the difference of squares is if you have 2 things that are squared, you can do it as a plus b and a minus b, or the difference or sum of cubes. That one's a little bit more complicated. But we'll go through each one of these in detail as we go through this section. So the first ones I want to look at are greatest common factor only. So the first 2 are only things that have a greatest common factor. So this 8s cubed plus 4s, you're looking for the number that will go into both 4 and 8, and you're looking to pull off the smallest exponent. So a number that will both go into 4 and 8 would be 4. 4 will go into 4, 4 will go into 8. And so I can pull out the 4 in front and the smaller of the powers. There's an s cubed and an s to the first, so I pull out the s to the first. What that leaves me with is what I would get if I was to divide each one of those things. So if I was to divide the 8s cubed by the 4s, I would get 2s squared. Or if I was to divide the 4s by the 4s, I would just get 1. And that would be my answer, 4s times 2s squared plus 1. So that way, if you were to do what we did in the last video, distribute it, 4 times 2 gives you the 8. You would add your powers, s squared and s gives you s cubed. And the 4s times 1 would be 4s. So you're really just dividing when we factor. Number 2, kind of the same idea. You're looking for the biggest number that will go into 8 and into 72. 8 will be both of those. 8 will go into 8 and 8 will go into 72. Notice they're both negative, so you could actually do a negative 8 if you wanted to. And so I'll do a negative 8. And then I pull out the lower power. There's an m to the 4th on both, so the lowest power will be the 4. And there's an n to the 4th is less than the n to the 5th on the first term. And so then I write down what I have left over. Again, you could divide it if you wanted to. If you took the negative 8 m to the 4th n to the 5th and divided it by the negative 8 m to the 4th n to the 4th that I pulled out front, the 8's cancel, the m's cancel, and 5 minus 1 leaves you just 1 n left over. Or if I did the negative 72, m to the 4th n to the 4th divided by negative 8 m to the 4th n to the 4th, dividing by what I pulled out in front. The letters all cancel, and 72 divided by 8 would give me 9. And that would be completely factored as much as possible. That's how you do greatest common factor. Then, number 3, you'll notice there are 4 terms here. I would do that by factor by grouping. And factor by grouping is a type of greatest common factor as well. What you do is you group the first 2 together and the second 2 together. And you factor out what's in common on each one of those. So on this first one, the v is in common. There's a v on both, so you can pull the v out, and you're left with the w plus x left over after you pull the v out front. On the second one, there's a k in common on both of them. Now for factor by grouping to work, what's left over in the parentheses have to match. And so they do. I have a w plus x on both of these. So I pull one of those in front, and then what's in front of those parentheses goes into a separate set of parentheses. So the v and the plus k. And that's your answer. You can always check these, by the way. If you FOIL it, you should get right back to where you were. Let's do a couple more factor by grouping. If you do factor by grouping and you notice that there is a negative sign right here in the middle, that negative sign right there, that tells you that on your second set of grouping, you have to take a negative out. And so when I do this grouping, I'll group these 2 together and these 2 together, but the negative will have to be pulled out front. So what's in common between the 2 and x and the 4 is only the number 2. 2 will go into 4, 2 will go into 2. So if I pull the 2 out in front, I'll have a 2 minus x left over. And remember, you're just dividing it. The 4 divided by the 2 leaves you the 2 in the middle, in the parenthesis. The 2x divided by 2 leaves you just an x left over. Between the 22y, the 11xy, there's an 11. 11 will go into both 11 and 22. And there's a y. There's a y on both of them. So I'm going to pull off a negative 11y. Again, negative because of the minus sign that I have the arrow above. So negative 22y divided by negative 11y will give you 2. And 11xy divided by negative 11y gives me negative x. Notice these 2 things are the same. So since they are the same, I pull one of them out front. And then I take the other parenthesis as whatever's sitting in front of those parentheses. So the 2 and the minus 11y. And that's your answer. Again, if you want to check it, FOIL it. If you FOIL it, you'll get back to where you started. Number 5, again, factor by grouping. I'll group the first 2 together, the second 2 together. Same as the one above it. Notice this minus sign right here means I'm going to have to take a negative out. So, what's in common between the 4st and the 10t? There's a 2 in common. 2 will go into 4, 2 will go into 10. There's also a t in common. So I could pull out a 2 and a t in common. If I do that, 4 divided by 2 is 2. The s is still there, and t divided by t goes away because that's just 1. The 10 divided by 2 gives me 5, and the t goes away. So what's in common between the 10s and the 25 would be 5. 5 will go into each one. Because it's a minus sign with the arrow above it, I'll take out a minus 5. And so negative 10s divided by negative 5 would leave me 2s left over. And negative 25 divided by negative 5 would give me 5 left over. Again, these 2 things here have to match, and they do. So I take one of them out front, the 2s plus 5. And what's left over is the 2t minus 5. And that's my answer. So hopefully factor by grouping is not too bad. You just have to make sure you factor out what's in common on the first two and the second two. So let's get into what's usually the ones that most people either remember how to do or the ones that you'll probably see the most of in different courses, and that's factoring trinomials. So you have three different terms. That's why it's called a trinomial. What you're looking for is a few different rules along the way. Notice there's no number in front of the squared terms on any of these problems. So if there is no number in front of the squared terms, what you're looking at is this sign right here. That is either a positive or a negative along the way, if you'll notice. If it's a negative, what that tells you is that when you draw your two parentheses, one of them has to be a plus, one of them has to be a minus. If that was a plus sign, then that tells you what they are, or that they are the same thing, either both positive or both negative. Then you're looking for these two numbers. You need two numbers that multiply to 32 that add or subtract to give you 4. So two numbers that multiply to 32 that add or subtract to give you 4. That would be 8 and 4. 8 times 4 gives you 32. 8 minus 4 gives you the 4. Since the 4 is positive, that makes the 8 have the positive and the 4 have the negative. The s squared just becomes s times s. And that's your answer. Again, you can check it by foiling. On number 7, notice this right here is a positive sign. So when I draw my two parentheses, if that's a positive, you look to over here to see what it is. The second positive tells you they are the same. The first positive tells you that they have to both be positive. If the 10 was positive and the 7 was negative, you would put two minus signs. So in this case, looking at these two numbers again, you need two numbers that multiply to 10 that either add or subtract to give you 7. That would be 5 and 2. 5 times 2 is 10. 5 plus 2 is 7. On this one, since they're both positive signs in our parentheses, it doesn't matter if you put the 5 first or the 2 first. The one above it, it did matter. The 8 had to go with the plus sign, and the 4 had to go with the minus sign to get positive 4 in the middle. But if they're both the same sign, both positive in this case, it doesn't matter if you put the 5 first or the 2 first. And then the b squared becomes b times b. And that's your answer. So hopefully this is making sense, especially if you've had struggled with this before. A lot of people don't notice that the rules of the positive and the negative in the original problem tell you what the positive and the negative are in the parentheses. Like here, this is a minus sign again. So if it's a minus sign, it always has to be a positive and a negative over here. Every time. So you're looking, these last two numbers, you need two numbers that multiply to 63 that either add or subtract to give you 7. So that would be 9 and 7. 9 times 7 is 63. 9 minus 7 is 2. Since the 2 is negative, the bigger number gets the negative, and the smaller number will get the positive. This one has c squared, so we'll go c and c. But notice it also has an f squared on the 63, so we'll have to do an f and an f as well. Again, if you FOIL this together, you should get c squared minus 2cf minus 63f squared. Now you might be thinking, yeah, I could do those, but I have trouble with the ones that have numbers in front. Like on this first one, 16x squared, or the number 10 here, 15x squared y squared. if they have numbers in front, I don't like those. Those are just harder to do. And so if you are in that boat, that's okay. What we'll do is we'll just get rid of the numbers in front. I'll take this 16 and multiply it times that 1 on the end. And say this is, and rewrite this as x squared plus 8x plus 16. And do the same thing we just did. The positive on the 16 says they have to be the same sign. And then you look over here, there's a positive there, so these both have to be positives. I would need two numbers that multiply to 16 that add to give you 8. So I would use 4 and 4. 4 plus 4 is 8. 4 times 4 is 16. So I would put a 4 here and a 4 here. The x squared becomes x and x. This, though, is not the answer. So because I did this multiplying by 16 on this original thing, I then have to divide by 16 everywhere. And make this 1/4 and 1/4. So officially that's an okay answer. You did factor it, but most of the time we don't like fractions in it. So what we do is we take the 4s and we'll put them back in front of the x's. And so your answer here would be 4x plus 1 and 4x plus 1. Or, if you wanted to combine them together, this is 4x plus 1 all squared. Either one is okay. So you may have seen this method before to get rid of the numbers in front. If you have, that's great. If you haven't, hopefully that makes sense. I'm going to do it again on number 10. I'm going to take the 15 and multiply it onto the 2. And rewrite this as x squared y squared plus 7xy minus 30. 15 times 2 is 30. And do my same thing I did before. There's a minus sign on the 30, so I need a positive and a negative. And so I need two numbers that multiply to 30 that either add or subtract to give me 7. And so I'm going to use 10 and 3. 10 times 3 is 30. 10 minus 3 is 7. Since the 7 has a positive, that means the bigger number gets the 10, gets the positive, and then the 3 on the negative. The x squared y squared would become xy. Again, that's not your answer because we multiplied by 15. So I'm going to divide each one of these by 15. And that will give me xy plus 10 over 15 doesn't simplify quite as well, but 5 will go into each one to make it 2/3. And 3 goes into 15 5 times. And just like before, we don't really like the fraction, so I'm going to take the 3 and move it over, and take the 5 and move it over. And so I'll have my answer to be 3xy plus 2 and 5xy minus 1. And that's my answer. Again, if you don't believe me, check it. Foil it out. See if you get the same thing I do. These next couple have to do a little bit more work because they have a common factor. You'll notice these are really given away by the fact that every single one of the terms has an n or a y on it. So if there's a variable all the way across on everything, then you're going to have a common factor. On the first one, it's a 3, a 9, and a 1380. So you might not can see it very well, but there is a 3 in common. So I'm going to pull a 3 out in common and an n out in common. Because remember, greatest common factor, the biggest number that will go into each of them, the smallest power on the variable. And then we look at that and divide them. The 3n cubed divided by the 3n gives me n squared. The negative 9 divided by the 3 is negative 3, and I'll have one n left over. And this one you might need a calculator for. 1380 divided by 3 is 460. Now, this is not your whole answer, because then you have to look and say, well, n squared minus 3n minus 460 is a trinomial. That might be able to be factored again. And so we look. There's a minus sign right here. So in my sets of parentheses, since that's a minus, I need to have a positive on one and a negative on the other. Then I need two numbers, based on these two numbers right here, that multiply to 460 that differ by 3. Now, this is definitely a situation you'll probably want to use a calculator for, because most people don't know the bigger numbers like that. But it actually would be 23 and 20. 20 times 23 is 460. 23 minus 20 would be 3. The 3 is negative, so the bigger number gets the negative. The smaller number gets the positive. And the n squared becomes n and n. And that would be your answer. Factor it as much as possible. And I'm going to do the same thing on number 12. There is a 4 in common all the way across. It's not quite as easy to notice it on the 540, but there is a 4 that will go into that. There's also a y to the 7th that you can pull out. So you pull out the biggest number that will go into each one, that's the 4, and the smallest power on the y. That's the 7. And so that will leave me with a y squared. 24 divided by 4 gives me 6y. And 540 divided by 4 is 135. And then we have to see, does that factor anymore? And it probably will. This minus sign again tells you that you need a positive and a negative. And you need two numbers that multiply to 135 that differ by 6. So let's see. I might have to go to the calculator for this one because I can't think of what it is off the top of my head. Okay, 15 and 9. So you may have found it faster than I did. So we're going to use 15 and 9. 15 times 9 is 135. 15 minus 9 will give me the 6. The 6 is negative, so the bigger number gets the negative. The smaller number gets the positive. And the y squared becomes y times y. And that's my answer. So hopefully factoring is, coming back to you if you haven't seen it in a while, or if you think, hey, this isn't so bad. Let's get into a few of the special rules. These are the difference of squares. So that rule says that if you have an a squared minus b squared, that will turn into a plus b times a minus b. So what you want to do is you want to rewrite each one of these problems as two things that are squared. Like, for instance, this first one, this is s squared minus 2 squared. So I have something squared minus something squared. And so my answer to that is to drop the squares off and put one of them with a positive and one of them with a negative. Oh, and then I wrote the squared on there by mistake. One of them with a positive, one of them with a negative. And that's my answer. And you can, like I said, FOIL it, see if you get the same thing. If I do number 14, I want to write everything with squares on it. So this is 16 would become 4 squared, y squared, and 3 squared is 9. So this will turn into 4y minus 3. You drop, or plus 3, doesn't really matter. But to make it match the rule, I'll put the plus 3. So you drop all the squares off and do 4y plus 3 and then 4y minus 3. And that's my answer. Again, FOIL it if you'd like. Now there is no rule. Notice this one has a positive sign right here. There is no rule that has squares on it that has a positive. You are able to write this as 12 squared b squared plus 13 squared. But that does not, this does not match that rule up there because it has to have a minus sign between it. And so since it has a plus, we actually say that this one is prime. Prime just means it does not factor. And so you might see one that is prime on the homework or the quiz or something. Okay, these are also the same rule. The same a squared minus b squared equals a plus b and a minus b. They're a little bit more complicated. This first one, you have r plus p squared minus 3 squared. So you can write it as a squared something minus a squared something. In that case, this turns into drop the squares off, put one with a plus, one with a minus. So we'll have r plus p plus 3 and r plus p minus 3. Notice the r plus p doesn't change because that got squared, so we leave it the way it was. We just drop the squared off and put it in each parenthesis. Or on number 17, c to the fourth, this goes back to your exponent rules a little bit. This is c squared squared. Because if you raise a power to a power, you multiply it. So I can go backwards and write c to the fourth as c squared squared. Minus 1 squared. 1 squared is just 1. And so I drop the squares off and write 1 with a plus and 1 with a minus. Now, if you were to stop there, you are not done. This also can be factored again. The c squared minus 1 is another difference of squares. The first one I can't do anything with. So it'll say c squared plus 1. That one is prime, kind of like number 15 was on the other page. But this second one is c squared minus 1 squared again. So I drop the squareds off, make one of them a plus, and one of them a minus. And that is as far as you can go. That's a little harder to check by multiplying it back out because you have to do it twice, but you could check it if you wanted to. Okay, let's talk about the ones with the cubes on it now. There are two rules here that we're working with, but they're really the same rule. If you have an a cubed minus a b cubed, that's what we have in this first one. This becomes a minus b times a squared plus ab plus b squared. So what it says to do is to write each one of them as a cube. So I'm going to rewrite this as a cubed minus 3 cubed. 3 cubed is 27. 3 times 3 times 3. And what I do is I drop the cubes off and do a minus 3. And then looking at the rule over here, this term to this term just gets squared. So the a goes to a squared. This minus sign gets swapped to a plus sign. So I get a plus. Then I take them together these two together get multiplied to go in the middle. That would be 3 times a, which would be 3a. It's always a positive at the end, so that's always going to be a positive. And then you square the last one, the b gets squared. And so the 3 gets squared to give you 9. And that's your answer. The second part does give you a trinomial, but that trinomial will never factor. So we'll leave it just like that. Now, if the rule has a positive in it, it's the same rule. The only thing that switches is the positive and the negative. So this will become a plus b instead of a minus b, and then we'll have a squared minus ab plus b squared. So if I rewrite this in terms of cubes, again, 27 is 3 cubed r cubed plus 1 cubed. So I drop all the cubes off first. That's 3r plus 1. Then the second set of parentheses, just like above on that other one, the first one gets squared. So 3 squared is 9, and then r gets squared. This positive will turn to a negative. So there's a minus sign right there. Then I take these two terms, multiply them together to put in the middle. The two terms in the middle, 3r times 1 is 3r. And then the last term gets squared and put on the end. 1 squared is 1. And again, on both of these, you could distribute it out and see what you get. You should get back to where you started. Most everything will cancel, and you'll be left with the 27r cubed and the plus 1. Okay, let's do a couple more. The 8x cubed minus 1, so that would be your rule for the a cubed minus b cubed. Or that becomes a minus b times a squared plus ab plus b squared. So if I rewrote that with cubes on it, this would be 2 cubed x cubed minus 1 cubed. 2 cubed is 8, 2 times 2 times 2. And so this would become, drop the cubes off, 2x minus 1. Then on our rule, we square the first one. So 2 squared is 4, x squared is x squared. Hold on, my wife is calling. Hello, dear.
Hey, did I mess you up?
Yes.
Sorry. Well, I wake up.
Okay.
Hi, I love you.
Love you. Bye. Okay. For those of you wondering and couldn't hear the phone, my wife is on her way home. So, after you square the first one, then we will swap that sign. So this minus sign will become a plus sign. We will multiply these two together to get the middle one. So 2x times 1 is 2x. And then we will square the last one. 1 squared is 1. And there you go. So we'll do one more like that. This is the rule for the sum of cubes, where we have the a cubed and the b cubed. This is a plus b. Oops, I wrote a 3. A plus b times a squared minus ab plus b squared. And so when I rewrite this one, this is 3 cubed times x cubed plus 2 cubed times y cubed. Write everything with a cube on it. And so I drop the cubes off. That's 3x plus 2y And then I do the same process again. Notice the first one gets squared. So 3 squared is 9. And then the x becomes x squared. The sign gets swapped. So this will now be a minus sign. I will multiply these two together to give you the middle. And so 3 times 2 gives me 6. And then I'll have x times y. And then the last one, I just square the b to get b squared. So 2 squared is 4y squared. And that's how you do factoring with a sum or difference of cubes. Now, all of that was sections 5.1 through 5.4 kind of all put together. The last part of chapter 5 is quadratic equations, where we will take a equation that has to be factored to solve it. So what we want to do is get one side equal to 0. You got to have 0 in the problem somewhere. Then we factor it, set each factor equal to 0, and then solve each one of them as a linear step. Now, sometimes you don't have to do each one of these steps. Like, for instance, you may not always have to get it set equal to 0 because it might already be set to 0. Or like in this first problem, it's already set to 0 and it's already factored. So all you have to do is set each one of these equal to 0. And then you have linear equations, much like what we had back in chapter 1, that you just have to get the x by itself. Subtract the 8 from both sides and get 11x equals negative 8. That's a negative 8 there. And divide by 11. So x equals negative 8 over 11. Or on the other one, add the 2 to both sides. And we'll get 3x equals 2. And divide by 3 on both sides. So hopefully this part is not too bad. We've done this part before. But you'll get usually 2 answers on a quadratic equation. And so you'll kind of see it where they'll usually have a box like this. And they just want you to put the 2 answers in with a comma between them. Like that. So hopefully that's not too bad. But most of the ones we'll do, I'll actually do factoring with it as well. So like on this first one. It's already equal to 0, so we don't have to worry about that. So I just need to factor the left-hand side. Notice there's a minus sign here. So that will tell me in my 2 sets of parentheses that I need a positive and a negative. And my numbers of 8 and 20 say I need 2 numbers that multiply to 20 and add or subtract to give you 8. So I'm going to use 10 and 2. 10 times 2 is 20. 10 minus 2 would give you the 8. The 8 is negative, so the bigger number gets the negative, the smaller number gets the positive, and the t squared becomes t and t. t and t. That's funny. I'm sorry. Once you get it factored, then you set each one equal to 0. So either t plus 2 equals 0, or t minus 10 equals 0. So we will subtract the 2 from both sides, and we'll get that t equals negative 2, or add the 10 to both sides, and we'll get that t equals 10. So our solutions would be negative 2 and 10. So as long as you can get it factored, it shouldn't be too big of a problem. On number 3, again, already equal to 0, so we just jump into the factoring. Notice this is a positive sign. If it is a positive, you look to the other sign to tell you what the sign should be. Since they're both positive, we'll have a positive and a positive. Then I look at the numbers. Two numbers that multiply to 40 that add to give me 13. So two numbers that multiply to 40 that add to give me 13. I will use 8 and 5. 8 times 5 is 40. 8 plus 5 is 13. Since they're both positive, it doesn't matter the order that you put them in. So I'm going to put the 8 first. And the m squared will become m and m. Oh, yeah, you got T and T, now you have m and m. It's the little things in life that get you through. So then you set each one of those equal to 0. M plus 8 equals 0, or m plus 5 equals 0. I can subtract the 8 from both sides, and I'll get that m is negative 8. Or I could subtract the 5 from both sides, and say that m equals negative 5. So my two solutions would be negative 8 and negative 5. And those are my answers. So hopefully that's not too bad. Now, this first one up at the top, you'll notice there is no constant term. There's a 2x squared, a 12x, but no number on the end, and it's already equal to 0. And so I don't have to get it equal to 0, but I do need to factor it. It's not a trinomial. It's only two terms. But this is a two-term where you have a greatest common factor. I know that because of this x right here. They all have x's on them, so I have to factor the greatest common factor out. And in this case, that would be a 2 and an x. 2x squared divided by 2x would just be 1x left over. 12x divided by 2x gives me 6. If I set each one of those equal to 0, I'll either get that 2x is 0 or x plus 6 is 0. So on the first one, I would divide by 2 on both sides to get x is 0. On the second one, you could just subtract the 6 from both sides and get x is negative 6. So I'll get the solutions of negative 6 and 0. On number 5, this is actually a difference of squares, or you can know the greatest common factor first. It doesn't actually matter, because 9 is 3 squared and 81 is 9 squared. But 9 does go into each one. So I'm going to pull the 9 out in front first. So if I pull the 9 out in front, I'll have a y squared minus 9 left over. It's still the difference of squares, though, because I can write y squared and 9 as y squared and 3 squared to make this be y plus 3 and y minus 3. Then I would set each piece equal to 0. The 9 does not get set equal to 0 because 9 does not equal 0. So I would only do the y plus 3 and the y minus 3. If you subtracted the 3 from both sides or added the 3 to both sides, I will get that y is negative 3 or y is 3. If you didn't pull the greatest common factor out and did it as 3 squared y squared minus 9 squared, you would get the same thing when you got done. So hopefully that makes sense. Okay, let's look at one that's not already equal to 0 and see what happens. So this one has a equals 6 on the right hand side. I need to move that over and combine it with the left hand side, but before I do that, I can't combine it if I have to FOIL stuff together. So in this case, what I'll have to do is FOIL this first part, the x minus 2 and the x minus 1. If I FOIL it, I will have the first ones. X times x gives me x squared. The outside would give me negative x. The inside gives me negative 2x. The last one gives me plus 2. And so that gives me x squared minus 3x plus 2 equals 6. So you have to FOIL it first. That way I can subtract the 6 to the left-hand side and get x squared minus 3x minus 4 equals 0. So you got to get it equal to 0 first. Once that occurs, though, then we can do what we were doing a while ago. We then have to refactor it based on the fact that the 4 is negative. So since it's negative, I have to have a positive on one and a negative on the other. And then I'm looking at the numbers. Are there two numbers that multiply to 4 that either add or subtract to give you 3? And hopefully you would notice that would be 4 and 1. 4 times 1 is 4. 4 minus 1 would be 3. Since the 3 is negative, the 4, the bigger number gets the negative, the smaller number gets the positive. And the x squared just becomes x and x. Then, each one of those becomes 0. So you either say x plus 1 equals 0, or x minus 4 equals 0. Subtract the 1 from both sides on the first one, add the 4 to both sides on the second one, and you'll get that x is negative 1, or x is 4. So my solution would be negative 1 and 4. By the way, on all of these solutions, you could take each one of those numbers, plug it back into the original equation, and make sure you got it right. Like, for instance, if I plugged 4 in, 4 minus 2 is 2, 4 minus 1 is 3. 2 times 3 is 6. So I know I got at least the 4 right. You could check the negative 1 as well. Okay, last problem. This one's already equal to 0, but you got some factoring to do. There is a y in common all the way across, so I want to factor out the greatest common factor of a y first. That will leave me a y squared, a minus 14y, and a plus 48. Then the y squared minus 14y plus 48, this positive sign right here, tells me that they are the same sign, so I look to the other sign in the problem to tell me what it is. Since that's a minus sign, then I know they're both minus. Then I look at these two numbers. Are there two numbers that multiply to 48 that add or subtract to give you 14? Well, 48 is, let's see, 16 times 3. That probably wouldn't work. It is 12 times 4. 12 and 4 won't give you 14. Let's try something else. 48 divided by 24 is 2. So 24 and 2, probably not a good option. So I'm going to use 8 and 6. 6 times 8 is 48. 6 plus 8 will give you 14. Since they're both minus signs, it doesn't really matter which one you put them in. And the y squared will become y and y. And that's completely factored. So you set each one of them equal to 0. In this case, the y in front does get set equal to 0. We did the one earlier where the 9 was in front. 9 can't be 0, but y can most definitely be 0. So you either get y as 0, y minus 8 is 0, or y minus 6 is 0. So I'll have to add the 8 to both sides of the one in the middle, and add the 6 to both sides on the one on the right. But y equals 0 is just y equals 0. That's one of the answers. So we'll get 0, we'll get 8. That's supposed to be an 8 right there. And we'll get 6. So my answers are 0, 6, and 8. Notice that when we did it with a squared as the highest power, we got 2 answers. When we did it as a cubed with the highest power, we got 3 answers. That's not a coincidence. Usually, your highest power on your variable will tell you how many answers you should get. That's not 100% of the time, but that happens a lot of the time. You cannot get more than that. So if it had a y cubed in the problem, you could not possibly get 4 answers. But you could get less than 3. You could maybe get 2 or just 1. But that usually tells you how many you're going to get. So that's the end of chapter 5. That's all the factoring. And so hopefully this makes sense. We're going to use all this factoring, all these techniques in the next chapter when we do factoring with rational expressions.